Today we're going to talk about a very odd thing in orbital mechanics, which is Lagrange points. Lagrange points are when we consider two bodies that are orbiting each other, so like the Sun and the Earth, and there are these 5 points which are very interesting. We use those points to put satellites in different places, like not orbiting the Earth, not orbiting the Sun, but orbiting in the sort of Sun-Earth frame. And we're going to talk about that today. So the reason that this is very interesting is because this is what's called a two-body problem. And so usually when we talk about the Sun and the Earth, we're talking about the Earth orbiting the Sun. The Sun is the main body, and the Earth is orbiting that. So that's considered a one-body problem because the Sun is the body, and then we talk about another object orbiting that. In a two-body problem, we actually have the gravity from the Sun, and we have the gravity from the Earth that we're considering at the same time. And we describe orbits then in those two bodies frames. In reality, we've talked about there being gravity wells within gravity wells within gravity wells. And so in reality, it's a million body problem. There's a classic physics problem, which is relatively easy to understand in that you have the Sun and you have the Earth, and you want to figure out where does the gravity of the Sun, which is pulling towards the Sun, and the gravity of the Earth, which is pulling towards Earth, where do those balance each other? And you can figure that out using some math, and it's basically like you set the distance to the Sun as one variable and the distance to the Earth as another variable, and you set the gravities equal to each other, and then you solve this. And it's relatively straightforward to do. But that ignores one big thing. What ends up happening is that the Earth is actually orbiting around the Sun, though. And so you have a third force. You have the gravity of the Sun pulling towards the Sun. You have the gravity of the Earth pulling towards Earth. And then you have this force called centripetal force. And that is the thing that keeps Earth orbiting the Sun. When we talk about orbits, we're talking about centripetal forces or centripetal acceleration. An orbit is where the gravity is equal to the centripetal force. All right? And so when we talk about a two-body problem, we have to consider the gravity of the Sun, the gravity of the Earth, and this centripetal force because these things are orbiting around the Sun. And so when we add those things together, we have these three forces. We have gravity of Earth, which is pointed towards the Earth. We have gravity of the Sun, which is pointed towards the Sun. And we have centripetal force, which is actually pointed away from the Sun. Now, interestingly, you may be able to see that there are points at which a lot of these arrows are opposite of each other. So between the Sun and the Earth, you have gravity pointed towards the Earth. You have gravity pointed towards the Sun. Those things are opposite. We've already established that we can find a place where they cancel each other. But then you also have this centripetal force that points away from the Sun. So if you add those three things together, gravity towards the Earth, gravity towards the Sun, and centripetal force away from the Sun, there is a point at which those things cancel each other out. And that is defined as one of the Lagrange points. That's Lagrange point 1. If you go on the other side of the Earth, away from the Sun, you have gravity pulling towards the Earth, which is actually towards the Sun now, gravity of the Sun, which is pointed towards the Sun, centripetal acceleration or force pointed away from the Sun. Now, there actually is a point out there at which gravity of the Earth, gravity of the Sun, and centripetal force, all three cancel each other out again, and that's called the L2 point. So you get these 2 points on the Sun-Earth line, L1, Lagrange point 1, and L2, Lagrange point 2, where these three forces all cancel each other out. And the reason for there being two of them is because on one side of Earth, gravity points this way. On the other side of Earth, gravity points that way. So they're in opposite directions if we zoom out enough that we're looking in the Sun-Earth system. And so you get a Lagrange point on one side of the Earth and a Lagrange point on the other side of the Earth. And both of those points are points at which gravity of the Earth, gravity of the Sun, and centripetal acceleration or centripetal force all cancel each other out. So there are actually 5 of these points. The other 3 are a little bit more challenging to describe, but they're all basically points at which forces are balanced with each other. The force of gravity of Earth, the force of gravity of the Sun, and centripetal force. All 3 of them balance each other out at these 5 locations. And we put satellites at some of these locations to actually help us in some ways. So more facts on Lagrange points. They are unstable. It basically is a point where there's no force or a balance of forces at that exact point. But if you go off it a little bit, you'll actually move away from that point. And so it's actually really hard to stay on them. So we actually orbit them. And so we're never actually at the actual Lagrange point. We orbit around those Lagrange points. Now, there are a lot of satellites that are sitting at Lagrange point 1, which is between the Sun and the Earth. And there are 2 reasons for this. The first is that if we look towards the Sun, we can view the Sun all of the time. We're never in the shadow of the Earth. If we look back towards Earth, interestingly, we can see the Earth in Sun all of the time too, because the Sun is shining on the Earth from our perspective at L1 all of the time. And so we have a satellite called Discover, which is sitting at L1 pointed towards the Earth, and it's just taking constant pictures of the Earth rotating around. And so we can measure things like climate change and stuff using a satellite at L1. At L2, we just have put the James Webb telescope, and that is away from the Sun, but it's actually, like if you were exactly at L2, that would be in Earth's shadow. So it's actually, we orbit around L2, so we're in the Sun all the time there too. So this video shows the 5 Lagrange points all orbiting the Sun. So you can see that they're all going around the Sun at the exact same rate as Earth is going around the Sun. This shows the trajectory of the James Webb Space Telescope. The arrow points towards the Sun constantly, which shows the James Webb Telescope out at L2. And it is orbiting around this L2 point. And the reason for that is that it needs to be in the Sun all of the time so it can get power. And if it was at the exact L2 point, it would be in Earth's shadow. And so it orbits around this L2 point constantly and takes data and sends that data back to us. So another interesting fact about L4 and L5 are these are points that are sort of 60 degrees away from Earth along the orbit of Earth around the Sun. So L5 is behind us and L4 is in front of us. And these are really interesting because they pick up asteroids and little comets. So those are regions where the force is very low. And so if you get an asteroid or a comet, which happens to sort of go through those points, it can pick those up and they basically stay in that area for long periods of time. For the Lagrange points for Earth, L4 and L5, there are some asteroids and comets in that area, but there aren't too many because Earth is pretty small, and so it's not that big of a deal. But if you zoom out and you look at Jupiter, Jupiter's L4 and L5 has a lot of comets and asteroids there. There are a lot of objects in Jupiter's orbit around the Sun at the L5 and L4 Lagrange points. Because Jupiter is so big and the Sun is so big, it collects debris there, basically. And so there are like little mini asteroid belts at L4 and L5 of Jupiter. So in summary, Lagrange points are a balance point between the gravity between the two bodies and the centripetal acceleration. There are 5 points for every pair of bodies: the Sun and the Earth and the Moon, the Sun and Jupiter, etc. And we use Lagrange points for satellite missions, allowing constant monitoring of the Sun or the day side of the planet at L1 or the night side of Earth at L2.